Hello and welcome to yet another video of Cornerstones of Math. Today we will solve this nice viewer suggested problem. If the summation of 1 divided by n times n plus 1 times n plus 1 factorial from n equals 1 to infinity has a value of k, then what is the value of floor of 3 minus k? Where the floor function means what is the greatest integer that is not greater than 3 minus k. Alright, let's get on to it. First, we need to evaluate its partial sum. Let's call this partial sum Sn. Then Sn is given by sigma, where I changes from 1 to n, 1 over I times I plus 1 times I plus 1 factorial. Here, notice that this 1 over I times I plus 1 can be written as 1 over I minus 1 over I plus 1. One of the most famous partial fraction formula. So the partial sum can be expressed as sigma 1 over I minus 1 over I plus 1 times 1 over I plus 1 factorial, which is 1 over 1 minus 1 over 2 times 1 over 2 factorial plus 1 over 2 minus 1 over 3 times 1 over 3 factorial plus 1 over 3 minus 1 over 4 times 1 over 4 factorial, and so on. And in the end, we have 1 over n minus 1 over n plus 1 times 1 over n plus 1 factorial. Now let us write this sum in a different way by grouping different terms. First, we write the very first term, 1 over 1 times 1 over 2 factorial. Next, let us write terms that contain 1 over 2. You can see them in here and here. So we have minus 1 over 2 times 1 over 2 factorial over here. And then we have plus 1 over 2 times 1 over 3 factorial. So we write minus 1 over 3 factorial. Similarly, if we collect terms containing 1 over 3, we have minus 1 over 3 factorial here, and plus 1 over 4 factorial here. So minus 1 over 3 times 1 over 3 factorial minus 1 over 4 factorial. And of course, the next term will be 1 over 4 times 1 over 4 factorial minus 1 over 5 factorial, and so on. And in the end part, we have 1 over n times 1 over n factorial minus 1 over n plus 1 factorial. So we have used this term, but we still haven't used this term. So we have to write minus 1 over n plus 1 times 1 over n plus 1 factorial in the end. So we have 1 over 2 at the front, and if we write this very last term next, we have minus 1 over n plus 1 times n plus 1 factorial. And this middle part can be written in sigma notation. Now it's sigma. If we use different index j, we have 1 over j times 1 over j factorial minus 1 over j plus 1 factorial, and j is from 2 to n. And this part can be simplified by using the common denominator j plus 1 factorial, which gives the numerator j plus 1 minus 1. So we simply have the summation of 1 over j plus 1 factorial, j from 2 to n. Now using this partial sum, we can finally find the value of the infinite series, which was denoted as k. It is the limit of Sn as n goes to infinity. So the limit of this, so 1/2, and this middle part goes to 0. And for this part, the finite sum now becomes the infinite sum. So the summation of 1 over j plus 1 factorial, where j goes from 2 to infinity. And luckily for us, this is the computable infinite series. using the famous power series definition of constant E. So the constant e is equal to the infinite summation of 1 over j factorial, where j starts from 0. In our expression, this part equals sigma 1 over j factorial, with j equals 3 to infinity. This equals to sigma 1 over j factorial, with j from 0 to infinity, which is e, minus the terms corresponding to j equals 0, 1, and 2. So e minus 1 plus 1 plus 1 over 2. So e minus 5 over 2. Therefore, the value of the sum is 1 over 2 minus e minus 5 over 2, which is 3 minus e. So the value of floor of 3 minus k is floor 3 minus e, so floor of e, which is 2. And that was all for today's video. Thank you for watching, and I will see you in another video.